All right, I'm going to do changes to the parent functions for you. You should be able to do all of these by the end. I'm going to set up the parent functions, and then I'm going to kind of go through the change pattern, all right? So our parent functions, linear, quadratic, that's x squared, cubic, absolute value, square root, cube root, no matter what, it's the same pattern on all of these. Just the equation looks just a tiny bit differently. But the same pattern for all of the pieces that are happening to it. So what we say is I'm going to use the quadratic just for sake of simplicity. We say it's f of x equals a x minus h squared. Sorry. Try again. F of x equals a 1 over b x minus h squared plus k. The only difference, let's say if it was absolute value, would be that it would be f of x equals a absolute value 1 over b x minus h plus k. So it still follows the same pattern on all of them, just what is there is going to change, okay? Now I'm going to talk about each of these things, each of the parts, and what they do. So our A, this is a vertical stretch if the absolute value of A is greater than 1. It's a vertical compression if the absolute value of A is less than 1. And it's reflected across y-axis. Wait, y. A is negative. X-axis. The x-axis if A equals negative. So two different things can happen here, which means if I have -3, there's two things happening. The negative is reflecting it across the x-axis. The 3 is vertically stretching it by a factor of 3. So we would say reflected across the x-axis, vertically stretched by a factor of 3. Now the b value is a little bit weird because it's 1 over b. So the number that I see here is actually the inverse, not this number, sorry, the b. So if I have something that tells me f of x equals 3x squared, this isn't b. B is the multiplicative inverse of this, which that means that b is really 1 over 3. So if b equals 1 over 3, that means that the absolute value of b is less than 1. So when the absolute value of b is less than 1, absolute value b is less than 1, it's horizontally compressed by a factor of whatever it is, whatever happened there. When the absolute value of b is greater than 1, it's horizontally stretched by a factor of whatever that number is. So this one, it's less than 1, so it's going to be horizontally compressed by a factor of 1/3. If b is negative, that's going to reflect it across the y-axis. This should be reviewed from when you were in Algebra 2. Now, h moves me to the left or to the right, and k moves me up and down. So let's do an example. So first thing I notice right away is that there is a b value, but it's not on the outside of parentheses, which it should be. So I'm going to rewrite this with it on the outside of parentheses, meaning I'm going to go 2x minus 4 by factoring 2 away from the x and 2 away from the 4. And now my b is in the appropriate notation. The reason I want to do that is, not notation, the appropriate format. The reason I want to do that is because this is showing me that it's going to move 4 to the right, but this looks like it moves 8 to the right. So I want to make sure I have it in the right format. So this is going to be vertically stretched by a factor of 3. It's going to be horizontally compressed by a factor of 2. Because remember, the b value is actually the multiplicative inverse of this, which is 1/2, which is the absolute value less than 1. So that's a horizontal compressed. It's going to move to the right 4, and it's going to move down, or sorry, up 6. Right and left is always what zeroes this out. What zeroes this out is positive 4, so that's to the right. And that's how we're looking at these.